So Albert Einstein once warned that if a person hasn't made their great contribution to science before the age of 30, they never will.
Yeah, I mean, think about that for a second. That is a genuinely terrifying quote.
Right. Especially coming from one of the most brilliant minds in human history. It just feeds right into that quiet fear so many of us have as we get older.
Oh, absolutely. It's not just the physical changes, it's that dread of intellectual decline.
Exactly. And that's why we're tearing apart the data today in this deep dive. We want to find out if your brain actually has an expiration date.
Or if that downward slope we always hear about is just, well, a myth we've all been sold.
Yeah, because we are looking at a rapidly aging global workforce right now.
We really are. Demographers even use this phrase, the specter of decline, to describe the economic and social panic around aging populations.
The specter of decline. Wow, that sounds grim.
It does. But our culture heavily associates youth with peak mental acuity, you know? And historically, early scientific studies kind of seem to back that up.
Right. Which is why today's deep dive into this academic text, Controversy 3, do intelligence and creativity decline with age, is just so vital.
It really is. We need to figure out if Einstein was actually right.
Do our brains just inevitably decay, or do they perhaps upgrade to an entirely different operating system?
To understand why everyone is so panicked in the first place, we really have to look at the traditional data that started the alarm bells ringing.
Right, the early tests.
Exactly. So for decades, the gold standard for measuring global intelligence was the WAIS, the Wechsler Adult Intelligence
Always
Scale.
ways, yeah.
And researchers kept seeing this very specific trend they ominously named the classic aging pattern.
Oh man, another grim name. So, okay, let's unpack this. What exactly is this pattern?
Well, the WAIS was designed to be highly comprehensive. It's divided into two main sections, a performance scale and a verbal scale.
Okay.
The performance side asks you to do things like solve complex, unfamiliar puzzles or arrange blocks into specific patterns under a time limit.
So it tests how you handle entirely new problems on the fly.
Exactly. Now, the verbal side, on the other hand, tests things like vocabulary, arithmetic, and general comprehension of the world.
And this is where the panic takes root, right? Because when you track performance scores across different age groups, they drop.
They do. The puzzle solving, that quick twitch reaction speed, it demonstrably drops off as we age.
But the verbal scores, the comprehension and vocabulary, they stay incredibly stable.
Yeah, and in many cases, they actually improve well into late life, which is wild.
That is wild. And that split in the data forced cognitive psychologists to draw a fundamental distinction between two types of intelligence, right?
Yes, fluid intelligence and crystallized intelligence.
Fluid and crystallized.
Right. Fluid intelligence is the raw, mechanical processing power of the brain. It's what you rely on when you encounter a completely novel stimulus.
Something you've never seen before.
Exactly. You have to figure it out on the fly. But crystallized intelligence is your accumulated knowledge.
So, like the facts, the vocabulary, all those life experiences you've banked over the decades.
Precisely.
Okay, so let me try an analogy here. Is fluid intelligence essentially like the RAM in a computer?
Oh, that's a good way to look at it.
Like it's your active processing power dictating how fast you can juggle new data.
Oh,
But crystallized intelligence, the pragmatic knowledge that's the size of your hard drive.
right.
So as the RAM maybe starts to slow down a bit with age, the hard drive is just getting absolutely massive.
Yeah, that's spot on. And what's fascinating here is how the underlying biology supports that hardware analogy.
Really? How so?
Well, as we age, there is a measurable decline in something called cognitive reserve capacity. Neurologically, the physical hardware of the brain undergoes changes.
Like actual physical degradation.
Yeah, for example, the myelin sheath, which is the fatty insulation wrapping around your nerve fibers, it can thin out.
Oh, wow.
And when that happens, the electrical signals in your brain literally travel a few milliseconds slower.
So the raw speed physically drops.
It does. Plus, there's an increase in neural noise, meaning the brain has to work a little harder to filter out irrelevant information.
But that's only half the story, right?
Exactly. The software in the crystallized intelligence becomes vastly richer and more complex with every passing year.
And if that crystallized hard drive keeps growing, I mean, it fundamentally changes how we interact with the world.
It absolutely does.
It shifts us away from just being really fast at solving abstract puzzles in a vacuum and moves us towards something much deeper.
We're talking about profound wisdom and emotional optimization.
Wisdom. That sounds hard to measure in a lab.
You'd think so, but psychologists have actually developed very specific frameworks to measure this shift.
Really? How do you test for wisdom?
Well, Paul Baltz, he's a pioneer in lifespan development research. He created a psychological test specifically to measure it.
Okay, I'm intrigued.
He wasn't looking for a single correct answer, because real life rarely has one. He wanted to see how people approached highly ambiguous, emotionally complex, real-world problems.
The example they cite in the text is intense, actually.
Oh, it really is.
Yeah, Baltus and his associates gave subjects this prompt. They said, a 14-year-old girl is pregnant. What should one consider and do?
It's a multi-layered, heavily loaded scenario. There is no simple answer there.
So what did the data show?
When Baltz analyzed the responses, over half of the top, most nuanced, and most deeply considered answers came from people over the age of 60.
Over half. That's amazing.
Yeah. He defined this wisdom as an expert knowledge system. But that doesn't just mean knowing a lot of textbook facts, you know?
Not just trivia.
Exactly. It means possessing a deep understanding of the pragmatic problems of living. It's the ability to transcend your own personal biases.
And to view a problem from multiple perspectives.
Yes, and crucially, to tolerate ambiguity.
That tolerance for ambiguity is huge, because young people might jump to a fast, rigid, black and white solution, right?
Yeah, high fluid intelligence, but low context.
But the older participants could see the gray areas because they had that massive hard drive of life experience to draw from.
Precisely. And this completely ties into Laura Carstenson's socio-emotional selectivity theory, or SST.
Right, SST.
Carstenson's theory completely reframes how we look at aging. SST argues that our goals, our motivations, and even what we pay attention to are dictated by our perceived time horizons.
Our perceived time horizons. So, like, how much time we think we have left.
Exactly. When you are young, your time horizon feels infinite. So your brain's primary motivation is to gather information.
You're relentlessly networking, meeting new people, banking knowledge for some nebulous future.
Right. Even if that knowledge isn't immediately useful. But when you get older, that perceived time horizon naturally shortens.
You realize time is a finite resource.
Yes. So your brain shifts its goals. Instead of banking random information or going to every networking event, you pursue emotional satisfaction.
You invest in sure things, you deepen existing relationships, you seek out meaning.
And what's remarkable is that Carstensen proved this isn't strictly tied to biological aging.
Wait, really? It's not just about getting old.
No. If a 20-year-old faces a terminal illness or lives through a severe epidemic or sudden political upheaval, anything that artificially shortens their perceived time horizon, their psychological goals, immediately shift.
They start resembling the goals of an older adult.
Exactly. It's a brilliant survival mechanism, and we see it play out neurologically in something called the positivity effect.
The positivity effect? What's that?
When researchers show people a mix of positive, negative, and neutral images, younger people tend to focus on and remember the negative information.
Which makes sense for survival, right, looking out for threats.
Exactly. But older adults show a striking preference for positive images. In fact, functional MRI scans have shown something incredible.
What's that?
In older adults, the amygdala, the brain's emotional processing center, literally fires less intensely when exposed to negative stimuli compared to positive ones.
Wow. So their attention and memory are actively operating in the service of emotional regulation. But wait, I have to push back here. If older brains are naturally pruning out negative information just to, feel good and savor the present moment, doesn't that make them less capable of tackling tough, gritty, real-world problems? Are they just putting on rose-colored glasses and ignoring the hard stuff?
It's a fair question, but the research points to the exact opposite conclusion, actually.
Really?
Yeah. This emotional regulation doesn't blind them to reality. It actually aids complex social problem solving.
Oh, so?
Because the amygdala isn't hijacking their nervous system with negative emotional reactivity or self-centered anxiety.
Oh, I see. They aren't getting overwhelmed by the drama.
Exactly. Older adults can approach heated interpersonal conflicts far more effectively. They have the emotional stability to zoom out, recognize larger patterns, and apply that crystallized wisdom.
Without their ego muddying the waters.
Yes, precisely.
Okay, so they aren't ignoring the problem. They're just refusing to let negative emotions hijack their processing power. But if older adults are wiser, better at emotional regulation, masters of social problem solving, does that mean they lose the fire in the belly required for explosive, world-changing creativity?
That is the big question.
Yeah, because that brings us right back to Einstein's warning and this massive clash between two major theories of creative aging we found in the source material.
Yeah, so the more pessimistic view here is Harvey Lehman's peak and decline model. Lehman spent years analyzing the ages at which practitioners across dozens of fields made their greatest contributions.
What did he find?
He plotted all this data and found a very distinct, alarming curve.
Lehman's data points are pretty startling. I mean, he looked at Thomas Edison, for instance.
Right.
Edison was an active inventor his entire life, but Lehman points out that Edison took out 312 U.S. patents between the ages of 33 and 36.
Which is incredible.
Yeah, that's more than a quarter of his life's work in a tiny 4-year window.
Right. And based on thousands of data points just like that, Lehman argued that superior creativity rises rapidly to a maximum in a person's 30s and then falls off a cliff.
Ouch. Why did he think that happens?
Lehman theorized that while older individuals possess greater erudition, they struggle when a situation requires an entirely new way of looking at things, like a new vocabulary or an untested technique.
So they get stuck in their ways.
Yeah, his argument was that the older mind becomes stereotyped and rigid. To learn something truly new, you often have to unlearn the old.
And unlearning established neural pathways is incredibly difficult.
Exactly.
But here's where it gets really interesting, though, because another researcher, David Galenson, looked at the same historical data and realized Lehman was making a massive assumption.
Right, Lehman was treating all creativity as if it's exactly the same.
Yes, but Galenson proposed that there are actually two entirely distinct types of creativity.
This is such a crucial distinction. First, you have the conceptual innovators.
Okay, what are they?
These are your young geniuses. They make bold, dramatic leaps. They work quickly, often guided by a highly abstract idea.
Think of lyric poets or theoretical physicists like Einstein.
Exactly. But Galenson contrasted them with experimental innovators. These are the old masters.
The old masters.
Right. They don't rely on sudden flashes of conceptual insight. Their process is deeply rooted in trial and error, continuous exploration, and the slow accumulation of knowledge over decades.
So because their creativity requires such a massive foundation of lived experience, they often don't peak until their 50s, 60s, or even much later.
Precisely.
So conceptual creativity is kind of like a lightning strike. It's sudden, it's bright, it reshapes the landscape in an instant.
Yeah, I love that analogy.
But experimental creativity is like carving the Grand Canyon. It takes decades of continuous, deliberate, relentless erosion to make something that beautiful and profound.
The Grand Canyon is a perfect visual for this because experimental creativity requires continuous friction and refinement over time. Our historians even have a specific term for it.
Oh, really? What is it?
It's called Alterstil, or the Old Age style.
Alterstil.
Yeah. As great artists age, their work often undergoes a profound transformation, stripping away the unnecessary to reveal something entirely new.
The historical examples in the text are just breathtaking. You have Rembrandt, whose brushwork became much looser as he aged.
Right, moving away from strict realism to become deeply preoccupied with the inner psychological world of his subjects.
Or Monet, who continued painting his absolute masterpieces, the famous water lilies, well into his 70s, even when he was confined to his home.
And Henri Matisse provides perhaps the most striking example of all.
Oh, his story is incredible.
In his later years, frail health forced him to completely give up painting, a loss of physical capability that could have easily ended his career.
But instead, he pivoted.
He did. He began creating colored cardboard cutouts. He distilled an entire lifetime of artistic genius into these incredibly simple, powerful, elemental designs.
The older mind discarded the need for mere technical perfection in favor of the absolute essence of the art.
Exactly.
Okay, so the capacity for old master creativity and profound wisdom clearly exists. The hard drive is full, the Grand Canyon is carved.
Right.
But what about the day-to-day? How do aging brains actually function in the workplace or in daily tasks if the raw processing speed is undeniably slowing down?
Well, the psychological term for how we handle this is decrement with compensation.
Decrement with compensation.
Yeah. To put it simply, you might lose a step, but you figure out a brilliant shortcut.
Yeah,
Humans are incredibly adaptive.
we really are.
We naturally develop strategies to offset those biological declines in speed by leaning heavily on our accumulated expertise.
The classic study they cite for this involves older versus younger typists, right?
Yes, it's a great study.
If you put them side by side, the younger typist has faster raw reaction times. Their fingers physically hit the keys quicker.
Right.
But the older typists maintained superior overall typing productivity.
How? because their crystallized expertise allowed them to read much further ahead in the manuscript than the younger typists.
They compensated for the loss of physical speed with a pragmatic, anticipatory strategy.
Exactly, which forces us to look back at that classic aging pattern from the Waste Intelligence test we discussed at the beginning.
Oh, right, the scary downward slope.
Yeah, we have to view those plummeting performance scores with a heavy dose of skepticism now. The flaw lies in the methodology.
How so?
Many of the studies that established that terrifying downward slope were cross-sectional. That means they tested a group of 20-year-olds and a group of 70-year-olds at the exact same time, say, in the year 1970.
Right. And the fatal flaw of cross-sectional studies is something called cohort effects.
Exactly. You aren't just measuring the biological difference in age. You are measuring the difference between entirely distinct generations.
Think about it. A 20-year-old taking a test in 1970 was born in 1950.
Right.
They grew up in the post-war boom with modern nutrition and were heavily conditioned by standardized testing in school.
But a 70-year-old taking that same test in 1970, they were born in 1900.
Exactly. They likely had significantly less formal schooling, survived the Great Depression, and had almost zero experience with timed, abstract puzzles.
So comparing their raw scores and calling it biological decline is practically scientific malpractice.
Yeah, it's totally rigged against them.
Furthermore, young people are highly accustomed to the pressure of timed tests. Older cohorts in those studies showed far more test anxiety.
That makes total sense.
And crucially, they tended to be much more cautious. On an IQ test, if you don't know an answer, it sometimes pays to guess.
But older adults, leaning on their wisdom, are often more reluctant to guess blindly.
Exactly. That caution artificially lowered their scores on tests designed to reward the impulsive, fast-paced mindset of youth.
Man, and the cultural fallout from this is severe. Researchers Becca Livy and Ellen Langer found that the societal stereotype of senility, the cultural joke that old people are forgetful and rigid, actually acts as a cognitive toxin.
A cognitive toxin. That's a powerful way to frame it.
Yeah, think about a common scenario. A 25-year-old misplaces their keys. They immediately blame it on being stressed or tired or just having a busy day.
Right, it's just a slip-up.
But when a 65-year-old misplaces their keys, that cultural stereotyping kicks in. They think, oh no, here it comes. My brain is failing.
And Levy and Langer found that when older people internalize these ageist attitudes, it literally worsens their memory performance in clinical settings.
Which makes you wonder, if society keeps telling you you're supposed to be forgetful and rigid after 60, does it become a self-fulfilling prophecy? Are we literally stereotyping our own brains into decline?
If we connect this to the bigger picture of modern neuroscience, the answer is yes.
Wow.
We used to believe the urban legend of aging, that you simply lose 1 million neurons a day and never get them back. But we now know the brain is highly neuroplastic.
Neuroplastic, meaning it can change and grow.
Exactly. It is constantly forming new neural connections throughout adulthood, a process called synaptogenesis. But neuroplasticity is heavily dependent on environment and belief. It is a use it or lose it proposition.
Which is exactly what the Seattle longitudinal study proved.
Yes, that study was a game changer.
To get around those flawed cohort effects we talked about, researchers didn't compare 20-year-olds to 70-year-olds. Instead, they followed the exact same individuals for decades, testing them repeatedly as they aged.
And the methodology produced a massive breakthrough. They found that intellectual decline is absolutely not inevitable.
Not inevitable at all. Anywhere from 60 to 85% of the subjects maintained or even improved their specific cognitive abilities over time.
Even more importantly, the Seattle longitudinal study demonstrated the power of intervention. When older individuals did begin to show cognitive decline, participating in specific spatial or reasoning training sessions could actually halt or reverse that decline.
Because of neuroplasticity. Their brains literally rewired and improved, rebuilding those pathways just like a younger person's would.
Exactly. Which perfectly explains the massive boom we are seeing in late-life education right now.
Oh, yeah. Programs like Rhodes Scholar or the university's The Third Age in Europe, they're exploding in popularity.
Millions of older adults are going back to school not to get a promotion at work, but purely for the intellectual challenge.
They are proving that complacency and rigid certainty are what actually kill creativity, while mindfulness and continuous learning keep the brain highly elastic.
The slight biological decline in fluid intelligence is real, but the trajectory of our overall intellectual capacity is highly malleable.
It's all about how you use it.
Yeah, if we remain engaged, if we challenge our own assumptions, and if we leverage that vast library of crystallized knowledge, the later decades of life can become a period of unparalleled experimental creativity.
So what does this all mean for you listening right now? It means we need to stop thinking of aging as a tragedy of losing intelligence.
Right. It's a trade.
Exactly. You might trade a fraction of a second in raw reaction time, but in return, you get the capacity for profound wisdom, superior emotional regulation, advanced pattern recognition.
And the ability to become an old master in whatever field you choose.
The story of your brain isn't a downward slope, it's an evolution. The question isn't whether your best days are behind you, it's what kind of experimental innovator you want to be with the decades you have left.
It requires a fundamental shift in how we value human intellect. We need to stop exclusively worshiping the lightning strike of the young genius and start deeply respecting the Grand Canyon carved by the old master.
I love that. And to leave you with one final thought to ponder today. We talked a lot about the positivity effect and the old age style in art, where creators like Matisse discarded all the technical fluff to focus purely on what was elemental and essential. Well, if our brains naturally prune away the negative, the anxious, and the unnecessary as we age to protect our emotional well-being, could it be that the ultimate pinnacle of human intelligence isn't actually about knowing everything, but finally figuring out exactly what is worth ignoring?
That is profound. The ability to filter out the noise might be the greatest cognitive upgrade of all.
Until next time, keep learning, keep carving that canyon, and we'll see you on the next deep dive.